So I forgot to turn this into clock time, but basically this is equal to, I think I simplified that wrong too. I think it simplifies to about 2.36 hours. Okay, so to turn that back into clock time, we have to add that to 12 o'clock. So the time of day should be at about 2, I think that works out to be about 2:22 p.m. Okay, but that's our clock. That's our time in decimal hours. I think it works out to be just under 22 minutes. Okay, take a look at. Let's take a look at question number 53. I think was the other one. So it says the illumination of light on objects is directly proportional to the strength of the source and inversely proportional to the square of the distances. Okay, so let's set up our system here. So this is number 50. What number was that again? 53. Number 53. We have a light source here. We'll call A, and I'm going to call that 3A because let's say that's a really bright light source. That's our bright one, and then we have B, and that's our kind of our dimmer light source. Okay, so this is really bright. And we're going to have some point. Let's call this distance x. Okay, and well, let's actually call it A. Okay. Sorry, I think the problem says, oh, they're placed 10 feet apart. Okay, so we don't need to make it. So we're going to make it 10. Okay, and then we're going to place a point here, arbitrary point x. And we know that the illumination is equal to, well, the illumination from A is going to be 3 times greater, so it's going to be 3 times, and it's going to be over x squared, because the distance x from here to here, that's a distance of x. Okay, we know it's inversely proportional. And we want to add that to the illumination from this side, so it's going to be, illumination has level 1, and it's going to be 10 minus x squared is inversely proportional to the distance. And we want to find out when the illumination is the least in terms with respect to x. So I'm going to differentiate with respect to x. I get negative 6 over x cubed minus negative minus 2 over x minus 10 minus x cubed, and then I have to times that by the negative on the x, so I'm going to get that. So there is my derivative. I'm going to simplify this. Negative 6 over x cubed plus 2 over 10 minus x cubed. So I want to know when this is equal to 0. So to make it equal to 0, I'm just going to move it over to the other side. So the negative to the other side. And then I'm going to solve this equation. Okay, so it becomes x cubed equals 3 times 10 minus x cubed. Okay, so I'm just going to divide the 2 on that side. Solve this. This is the nice thing about this equation is we don't need to multiply it out because these are perfect cubes. I can cube root perfect cubes. So I get x equals the cube root 10 minus x. And then group my x's together. I get x times 1 minus, or 1 plus, cube root 3. Move that 10 cube root, the cube root 3x to this side. And then I'm going to keep the 10 cube root 3 on this side. And then the position is going to be 10 cube root 3 over 1 plus cube root 3. A as a decimal value, let's work that out. 10 cube root 3 divided by 1 plus cube root 3. And it's about 5.91. So 5.91 feet away from the brighter source. So it's closer to the dimmer source to get the least amount of light.